Okay, so therefore let's use the protocol in the previous video, alright, the I2C protocol or I2C protocol, to actually help us to look at how the data are being transmitted. Alright, the bottom one, this thing over here, alright, are all called the SDA. Alright. So at first, before you start, alright, to start the transmission, you're gonna pull your SDA from high to low. So at first it's all high, right? Because as you can see, your SDA will be high all along. Alright. As long as if this switch is closed in this case, then your SDA will actually be low. Right? That's just the thing. Okay? So therefore over here, at first your SDA is high. Okay? Then after that, once you close the circuit, you'll become low. Alright, once it's low, then this particular low part will actually low for a bit of a second or whatever. I don't know how much, some milliseconds I would say. But after this particular low, because high to low, right? So at this low over here, then at a particular point it will start to vroom up already, and it will start to send bit. So over here it will start to send your stuff information from the system, alright, or you can send from your Arduino to your particular device that you want, or you can receive also data from there. Alright, so over here, this particular portion over here is to initiate the start that you are starting to transmit your signal, alright, or transmit your data. Okay, and make sure that your SCL is high. This whole chunk over here is your clock SCL. So over here, this is always high. Alright, up to the point when you start, alright, then you'll start to do the same thing to help you count the byte. Alright, so each of this thing initiate 1 byte. So I should say that this is 1 byte. Sorry, not 1 byte, 1 bit, 1 bit, 1 bit, 1 bit, 1 bit. For each of the high, this particular high, alright, over here, then low, then high again. For each of this high is 1 bit. Alright, so it's trying to take in 1 bit, 1 bit, 1 bit, 1 bit all along. Okay, so it helps you to calculate 1 bit by 1 bit, how much seconds do I take for each of the bit to be taken in. Alright, so the clock is how it is being done over here. So for example, this is at time 1, this is at time 2, time 3, etc. Alright, this is, I should say that this is by time. For example, time 1, time 2, 3 all the way. Alright, so at first this first signal is being sent. Alright, so each of this data will be written over here, for example 1. Okay, and then the second data is being sent, it becomes 0. Alright, the take data will be sent, it will become 0 over here, so on. So I'll have 1 and then 1 0 1 1. Okay, so this thing over here is being sent in this manner. Each by bit by bit it sends. Okay, and therefore this thing over here is the less significant one. Alright, and this one is the most significant bit, because if you still remember, this is 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, this 2 to the power of 7. Alright, I think 8 bit, right? Yeah, anyway, I forget already, but at least you get to know these are in terms of the power. So the most significant bit is the highest power, where the least significant bit is the lowest power, 2 to the power of 0. Alright, so therefore I think this, at least you get to know how this is coming up. Alright, so therefore this thing over here, your less significant bit, is first sent here, then the second one is then sent here, and the third one is continue to send and build up this 1 byte 8-bit stuff. Okay, I hope this is pretty clear, so at least you get a feel of things. And therefore when you reach a certain signal over here, alright, you require 1 more byte. Alright, or you require 1 more bit over here. This is 1 bit. Alright, this is 1 bit, and this particular 1 bit is to send to your Arduino. Alright, so you have connected your device. For example, I at first it's high, right, and then after that at first it's high over here, and then I close this circuit, I'll become low. Alright, so at the last part over here, which is denoted by over this side, over this one, okay, we'll send the last bit. Alright, so it's the 9th bit. Alright, so it will not interfere with your information. Alright, so over here, these are all your 8 bits. Alright, your all information is being sent already. So at the end of the day, the device itself will own self generate one more bit, alright, to send to the Arduino, telling the Arduino that okay, this is the end of the transmission. Alright, so therefore this is the meaning, alright, of this portion over here. Alright, it says that so it says that the receiver sends acknowledgement of a 0 bit. So you'll send it use a 1 bit clock SCL to send a 0 bit SDA. Alright, over here this is 0 right? So you use a 1 bit clock SCL because for the clock to work you need it to be high, right? So therefore for a clock to work you send a 1 bit, you require it to be high, and then when the clock is high you send a 0 bit SDA or 0 bit data just to inform the Arduino that we have stopped, please stop sending or receive signals from my device. Alright, and therefore after this particular bit over here, alright, you'll start to slow down and then goes to 0, and then over here it will stop. Alright, so your device will open up. So after you send to the Arduino, then the device, this circuit will open up, and then after that this thing will continue to float high. Okay, so your VDD will float high, your Arduino will continue to supply a high voltage or high current throughout here. Alright, until the next time another system gonna tap in again, and then everything is gonna repeat this process again. Alright, if you don't know anything, you'll just click back a few minutes ago and then you rewatch. I think it is pretty, clear, I guess. Yeah, anyway, so this method, alright, can also be implemented within the software. Doesn't have to be together with the device. Alright, because now what we're doing is device to device, right? Because we talk about sending one signal from the Arduino to the device and things like that. Alright, this can also be happening if you are dealing with softwares. Alright, so if you are dealing with this software, and the software is being programmed by the programmer to specify whatever thing in the details, and then you're gonna send it to the digital input or output. This IO is input or output pin, alright, and you can use it already. Alright, so you can use your I2C in this manner. Alright, so this is just to tell you that your I2C can be used in this manner, so to speak. Again, your I2C or I2C can be implemented in this form, alright, through a software. So you program it such that your device can actually can actually interact with another device. So you are using a code or programs to actually help between two systems to talk to each other and things like that. So I take back my words stating that previously we say that device talking about it, and then I say that we can also use in software, but anyway we use the software to help the device to talk to each other. So yeah, it's my fault, I didn't read properly. So therefore I repeat again, the software that programmer said is help to let Arduino and whatever device that you want to talk to actually connect to each other. Alright, so this particular the code itself will actually form somewhat like the SDA protocol. Alright, so that you can tap along with other devices and things like that. Alright, hope that this is pretty clear. And using a program to actually code your I2C is actually called a bit banging. Alright, so you may need to understand this word. For 1 megahertz clock or your SCL, alright, this is one of the wire besides SDA. You remember your I2C has 2 wires, one wire is SCL, one wire is SDA. This is for data, this is for the clock. Aha. And therefore for 1 megahertz, alright, you requires 100. You can actually send 100 kilobytes per second or 10 instructions per second. That's the meaning. It's something for you to know lah. I think just listen and then put it inside your brain. So in the future, happen that if the test asks you, at least you know. Anyway, so if the clock is unable to process more instructions because we are limited by 1 megahertz, alright, then we're gonna look for synchronized serial port. Alright, so what does this mean? So the synchronized serial port is that the main program will move whatever data that you're transmitting to a special place or register, and then this special place will help you to process all the tasks all at once. Alright, and it's macam like a outsourcing. So you outsource all your data that is all the instructions, or such that is more than 10 instructions or more, or you can actually outsource to a certain place other than your particular So you have a microcontroller over here. So you outsource all your data, synchronize it with your clock, and then this particular system over here, some arbitrary synchronized serial port, some other serial port over here will help you to sort out the data. And once it's set, you'll send back to your microcontroller, and your microcontroller will actually send back to your Arduino. Actually, your Arduino is your microcontroller. I mean your I2C lah. Okay, sorry. This should be I2C. Alright, so your I2C will send whatever thing to your whatever serial port that it says, and after that the serial port done already, you'll send back to your I2C reader or whatever, and then you'll send back to your Arduino. Alright, or things like that. Alright, it's not very clear. But anyway, at least you get a feel, and in fact it doesn't I should have said that the Arduino will connect to the device if your SDA is connect. So you have multiple devices, as we have been talking along. You have many devices, device 1, 2 and 3. Okay, so you're gonna connect float high, as long as your switch is all open, correct? And then if it happen that if you want to connect to this device, so you'll connect to this device and closed loop. But however, if it's many instructions, this device will actually sense and will outsource to another serial port. So this particular serial port will process your stuff. After that, it will send back to your device, and your device will send back to the Arduino. Okay, things like that. So I hope that this is somewhat pretty clear, and this is called a synchronized serial port, where all the processes that happens throughout this outsourcing stuff is synchronized by the SCL also, or your clock. I think that's the meaning lah. Okay, so just forget what I said in the previous part. Just remember, just somewhat understand this lah. I may still be wrong, but at least something lah. Okay, but it says that you no need to remember these details. Yama. So therefore, never mind. But anyway, just take note that the clock, your SCL, defines when the data are valid. Why? Is because if you were to just take a look over here, this thing, as long as your clock is high, you're gonna take in your bits. You see over here, you're gonna take in your bit. As long as it is high, you're gonna take in one bit. Alright, so everything is dependent on the SCL. So if the clock SCL is always low, then you aren't taking any bit at all. Alright, so you aren't sending any byte or any stuff to the Arduino. Alright, so this is the meaning. So please take note of that. This particular sentence, your clock defines when the data are valid. And therefore, lastly, we just want to introduce you with another stuff, because often there is also a separate clock. Alright, so there is no other separate, so I should say that there is no other separate clock. So therefore, previously we have SCL. Alright, however, we can also have no clock at all. Alright, so the clock itself is coded within your system. Alright, and can be recovered by data from the device that you receive. Alright, so we can also have no clock, but in a sense that the system itself can in some sense calculate by itself. Alright, so in some sense it can calculate by itself without having a clock to actually synchronize your stuff. Alright, and therefore the USB actually work in this manner. Alright, so therefore if happen that you don't understand what the hell am I talking in this video, this video is particularly trying to explain to you for the I2C protocol, how is it being shown graphically and how the data are being sent. Alright, with regards to the synchronizing of your clock and your SDA data. Or SDA is just a serial data that you send 1 byte by 1 byte by 1 byte, you see? 1 bit by 1 bit. So you send 1 bit by 1 bit, and therefore this is called a serial data. I don't know what is it called, SDA lah. Okay. So in this system is always talking about having a clock. Alright. So in the next video we'll talk about if we have no clock, can our SDA still send data? Okay. So therefore I shall see you in the next video.